Have you ever wondered how the sky creates its own symphony of light and sound during a storm? Welcome to a journey of discovery, where we untangle the secrets of nature's most electrifying performance, the spectacle of thunder and lightning. There's a world of science hidden in every flash of lightning and each rumble of thunder. These phenomena, often shrouded in myths and misconceptions, are integral parts of our planet's weather system. From tales of divine wrath to misrepresentations in popular culture, thunder and lightning have been mystified for centuries. But what if we told you that these spectacular displays are not just random acts of nature? They are an elaborate dance of physics and chemistry, a delicate balance of heat, light, and sound. As we journey through this exploration, we will debunk the myths and reveal the fascinating truth about these natural phenomena. As we delve into the science of thunder and lightning, prepare to be amazed by the intricate workings of nature. The dance of lightning across the sky is a result of a fascinating scientific process. Now let's delve into this ballet of nature and understand how it all begins with the seemingly innocuous act of charge separation in a cloud. The stage for lightning is set within cumulonimbus clouds, those towering anvil-shaped clouds that often herald a storm. As these clouds grow and churn, they create a kind of natural particle accelerator. Warmer air carries tiny ice crystals upwards while heavier hailstones fall downwards. As they collide and scrape against each other, electrons are stripped away, creating a separation of charges. The lighter ice crystals acquire a positive charge and accumulate at the top of the cloud, while the heavier hailstones, now negatively charged, gather at the bottom. This process sets up a dramatic electrical potential within the cloud, and even between the cloud and the ground, which also develops a positive charge in response. But nature abhors imbalance, and so begins the second act of our celestial drama. The electrical potential continues to build until it's too powerful to contain. At this point, nature pulls the proverbial trigger, and the stored electrical potential is released in the form of a lightning strike. This discharge doesn't happen all at once. It begins with a stepped leader, an initial surge of electrons that zigzags downward, seeking the path of least resistance. As it nears the ground, an upward streamer, a positive charge, rises to meet it. When they connect, the full power of the cloud is released in a return stroke, which is the brilliant flash we see as lightning. So that brilliant flash in the sky is essentially electricity seeking an easy path to the ground. This awe-inspiring spectacle is not merely a beautiful display of nature's power, but a testament to the incredible scientific processes that govern our world. From the simple act of charge separation to the dramatic release of a lightning strike, it's a dance of elements, a testament to the grandeur of the natural world. Now that we understand the light show, what about the thunderous applause that follows? Imagine for a moment you're at a grand concert. When the orchestra strikes a note, the vibration travels through the air, reaching your ears and creating the sensation we know as sound. Now let's take this analogy and apply it to our natural symphony of lightning and thunder. When a lightning bolt tears through the sky, it's not just a visual spectacle, it's an event of immense energy, so powerful that it heats the air around it to a staggering 20,000 degrees Celsius. This is hotter than the surface of the sun. Now, air, like anything else, expands when it's heated, and in this case, it expands explosively, creating a shockwave that radiates outwards from the path of the lightning bolt. This shockwave travels at the speed of sound, around 760 miles per hour. Initially, it's supersonic, faster than sound itself, but as it moves further from the lightning bolt, it slows down and becomes an audible sound wave. This is the first crack of thunder you hear, sharp and abrupt. But the story doesn't end there. As the shockwave travels, the air cools down again, contracting rapidly. This contraction creates another shockwave, this time moving towards the path of the lightning bolt. When this wave collides with the still expanding air, it generates a series of smaller shockwaves. These echo off each other in the surrounding landscape, creating the rumbling sound that follows the initial crack of thunder. So, the next time you hear a roll of thunder, remember, it's not just an echo of the lightning bolt. It's a testament to the power of nature, a symphony played out in heat and sound, a story told by the air itself, in response to the lightning's powerful command. So, the booming sound of thunder is simply the air around the lightning bolt telling its story. Ever noticed how we see lightning before we hear thunder? There's a simple explanation for that. This phenomenon is all due to the speed at which light and sound travel. Light, in the form of lightning, zooms through the atmosphere at an astonishing speed of nearly 300,000 kilometers per second. In contrast, sound, or in this case, thunder, travels at a much slower pace of approximately 343 meters per second. So when a lightning bolt streaks across the sky, the light it emits reaches our eyes almost instantaneously, while the sound of the thunder created by the same bolt lags behind. It takes its time, leisurely rolling over the landscape towards us, giving us that characteristic delay between the flash and the rumble. The dance between light and sound in a thunderstorm is a beautiful example of nature's symphony, choreographed by the laws of physics. So it's not that thunder is slow to react, it's just that light always steals the show. Indeed, the symphony of light and sound in a storm is a marvel of nature's science. The formation of lightning, a spectacular light show, begins with the buildup of electric charges in a storm cloud. When this charge becomes too great, a bolt of electricity streaks across the sky, creating the flash we know as lightning. Now let's not forget the roaring applause that follows this performance, the sound of thunder. This is caused by the rapid expansion and contraction of air surrounding the lightning bolt, producing a sonic shock wave we hear as a thunderous boom. Understanding these processes can help us appreciate not only the immense power of nature, but also its breathtaking beauty. It's a dance of light and sound, a symphony conducted by the laws of physics and brought to life by the energy of our atmosphere. So, next time a storm brews, sit back and enjoy nature's symphony, knowing the science that orchestrates the spectacle.